Says there, electric charges is measured in coulomb. What is electrostatics? It's the study of charged or electrical charged particles that are static. What does the word static mean again, Amora? Your brain is a bit static at the moment. Not slow. Anyone? Really? Let's say who? It means, say again? It is stationary, meaning not moving. Yes, when I asked you a question, you froze. Not? Alright, so static means charges, particles that are actually not moving, they are staying where they are. Now, the smallest particle that we know of currently are electrons and protons. Electrons have a charge of 1.6 times 10 to the power negative 19, and it's negative. And protons have exactly the same size, but it is positive. Now, when you have your data sheet open next to you, close to you, then you'll see I actually give you the charge of an electron. So on your table there, info table, the fourth thing there, it gives you the charge of an electron, and it gives it to you at negative 1.6 times 10 to the power negative 19. Do you see the charge of a proton on there? No. But they have exactly the same charge. A proton is just positive. Okay, so that will be given to you. We are now working towards, where are they? Okay, follow the data sheet that is missing here. There you go. I will show you in a moment. Alright, then that just means that they move. So when we say there's 1 coulomb does not mean 1 electron. 1 coulomb means there's 6.25 times 10 to the power 18 electrons that move. That is a lot of electrons. Okay, so it's so many electrons that pass. Okay, so 1 coulomb does not mean 1 electron. It means a lot of electrons. Okay. Then, something that you did in grade 8 is when we have a neutral object, it means there's as many protons as electrons. They have equal amount of protons and electrons, right? Can an object have, when we say object is neutral, can it mean, or it doesn't mean it has no electrons or protons? No, if it has no electrons and protons, it does not exist. It's nothing. Okay, so a neutral object has electrons and protons. They are just equal number of. So neutral means the number of electrons is equal to the number of protons. Have you seen those symbols before for an electron and proton? Never! Oh my goodness. So an electron is the E with a streepie there, which means it's negative. And a proton is the P with a plus for positive. Electrons, protons. Okay. When an object loses electrons goes away, then it becomes positively charged. Because it lost negative things, so then there's more positive things. When an object gains electrons, it becomes negatively charged. Can an object gain or lose protons? Really? Can an object gain or lose protons? Can an object, a person, lose protons? If it loses protons, it's an atomic bomb. Have you seen that happen to a human being? No. But it can lose electrons. If I just do this and I touch something, I'm losing electrons. And then when I touch something else, I gain it again. So electrons flow randomly the whole time. But protons you can never remove or gain. Then it's an atomic bomb. It's a fission or fusion bomb. Alright. Yes. Say again, if you choke on something. Well, yes, electrons, yes. Right, so, sorry, for the next class, make sure, please, you have, or the person next to you, you're going to share a eraser and a ruler. Right, for the next class. It's not a must, I just want to do a small experiment. Alright, then the first principle there is the principle of charge quantization. Okay, it says there, the definition. All charges in the universe consist of an integer multiple of the charge on one electron. What is an integer to me? What does that word mean? This word here. It's the number. It's the whole number. Okay. Integer multiple of charge of an electron. What did you just highlight? Do you know? It just means if something has a charge, something is 1 coulomb, 2 coulomb, whatever, then it just means it must be that the object has 1 electron or 2 electrons or 3 electrons or 4 electrons. So it must be the charge of an electron times how many electrons it has. Okay, you can't ever have a half of an electron. Your charge can't be half electron because you can't split an electron in half. Okay, right. So to calculate how many electrons something has or how many it lost, we're going to use this formula that calculates the excess or shortage of electrons. Now this formula, I want to say it's on your data sheet. I just want to double check because my knowledge, I put it in your test. Yeah. So for some reason there is a no, it just didn't print. Okay. But you have the this formula is on your data sheet. It will be given to you in a test or exam. Yours is just a capital letter Q. Okay, but it means the same thing. So if you want to know how many electrons, so N stands for the number of electrons something has an excess or shortage of, then you're going to take the charge of the object divided by the charge of an electron. Okay, which will be this thing E is on your data sheet. Okay, so let's see how this works. It says an object has a charge of -8 nanocoulombs. All right. Omulemu, when something has a charge of -8, does it mean it has an excess of electrons or a shortage of electrons? Is an electron positive or negative? Negative. So if it has a negative charge, it means there's more negative things than positive things. Yes? So in negatives, you shouldn't think of it lost things. Negative, you should think of what is negative. Electron is negative, so it has more negative things. So this thing means it has more, that -8 means it has the electrons is greater than the number of protons. So it gained electrons from somewhere, it was rubbed or whatever, and it gained electrons. And they now want to know how many excess electrons are on there. Sometimes, especially in winter time, especially in the Free State, when you take out your jersey, the sparks that goes off. Nay? Never. When you take out your jersey, we will do the experiment with you in winter and you will shock. Alright, when you do that, it's because the whole day you were busy, you're moving like this with your jersey and your backpack and whatever. And then there was a charge build up, and as soon as you take it off, there's a discharge, and I'm going to show in a simulation in a moment. So then charges are transferred, so then you're back to normal again. So here something happened during the course of the day. There was a bit of friction or what, and there's a charge buildup. So now it means there's more negative things than positive things. Okay, so it doesn't mean it has no positive things. If it has no positive things, it will not exist. Okay, secondly, Atlehang, it says there NC. What does NC stand for? Say again? Nanocoulomb. So they tell us the charge Q, or lowercase q, you can use any one, capital or lowercase. They say the charge there is -8 nanocoulomb. Now, we do not want to work in nanocoulomb, we want to work in coulomb. How do we go from nano to normal? Look at the top of your page. Times 10 to the power of? To go from nano to coulomb. To the power of -9, because you're going that way. Okay, now they ask how many, so the number of, how many excess electrons does it have? So the number of electrons, excess electrons, they want to know. Alright, if you look at this formula, you see we are missing E. I see now, where will we find E in a test or in an exam? On the data sheet, it's -1.6 times 10 to the power -19. Right, so we have N is Q over E. Then you substitute your values. Okay. Yes, ready when you are? And then you'll just say electrons. Yes. There's someone I must help with their calculator. I just want to say something. I don't know if you do it. I don't think so. But can you see that I don't put in here coulomb? Okay, when you substitute values, you never put in the unit with it. Your unit just goes at the end with your final answer. Okay, so you don't put the unit in between. Right, let's look at the next one. It says there, a sphere. Now, where are we with the questions? Carabello, what is a sphere? It's like a circle. But a circle can be seen as two-dimensional. One-dimensional, just like this. But a sphere is a round thing, like a ball is a sphere. Okay, a sphere has so many excess electrons. What is the charge on the sphere? Okay, so they tell you now the number of excess electrons, the number of too many electrons that it has, is 4,0625 times 10 to the power 10. That's how many electrons it has too much. Now they ask, what is the charge? Karabo, what is the symbol for charge? That is the, yeah, Q. That's what I'm looking for. Alright, and the charge of an electron is on your data sheet given. Now let's say, when they say it has excess electrons, too many electrons, your prediction, what will Q be? Will Q be positive or will Q be negative? If the charge or the sphere, has excess electrons, will Q be positive or will it be negative? Say again? Positive. So it has excess electrons, too many electrons. Electrons are positive or negative? So it has too many negative things. Will Q be positive or negative? It will be negative. Okay, so we are thinking our answer should be negative. Yes? All right. So we're going to write down a formula. N is Q over E. Remember, you write down a formula exactly like it is given on your data sheet. Then you're going to substitute your values. And then only do you rearrange. Okay, the left, when you're done writing, we want Q. So we need to get rid of this. What are you going to do with this? Yes, with that side. Okay? So you're going to type in 4,0625 times 10 to the power 10 times 1. Exactly 0.5. 6.5. Oh, yeah, times 10 to the power of -9. To get a positive answer, you multiplied a positive thing with a negative thing and you got a positive answer. So it should be a negative answer, Coulomb. Okay. Yes? Easy peasy. Alright, now we're going to look at the transfer of electrons. What's wrong? Why do you get 14? Why do you have a 5? It should be 10. Oh. Yes? Yes, that's what I said at the beginning of this year.
No, ma'am, I didn't do it as
All right. Where do I want to go? So, okay, so I'm back at the Phsc simulations that we have done. I just want to quickly. All right. So first thing here is okay. There's a man, and he can rub. Oh, wait a minute. What's happening here? There's something. Okay. Anyway, right. So he can move his leg and he can move his hand. All right. So he is on a carpet, and his hand can move to the door handle. Do you know who this is? This is John Travolta. No. Have you ever watched Grease? No. Sure. All right. Anyway, he's the man in Grease, and they're making fun of him. All right. So when he rubs his foot on the carpet, there will be friction. Okay? Like when you do this, then you feel there's friction. So you can see there's friction, and as he does that, there's a charge build-up. So you can see, So you can see from his, I don't want to read. From the carpet, the charges are transferred onto his leg or onto his body. right? So there's friction there, there's rubbing, and then there's a transfer from the carpet to him. And electrons are negative. What do we know about negative and negative? Okay, no, not like in mathematics. Like you have a negatively thing and a negative thing. What will they do? Will they be attracted to one another? No, they will repel one another. Right? So you can see here what the electrons does. Okay, it's now moving quite slow, but it has moved so it goes far away from each other. It's spreading out until it's at its whole body. Okay, so it spreads out because negative things do not want to be close to one another. And now when he's going to bring his hand close to the door handle is made out of metal, and it would like to attract electrons. And then you see there is a discharge, and it shocks. Okay, why does it shock? Because the door handle is neutral, doesn't have a charge, and he is negative. So there is unlike charges. So it's not always positive and negative. Something is neutral, something is negative, and this one can feel that this one has too many excess electrons, and then the electrons go to the thing that is neutral. Okay, so that is when it shocks, and that is what happened last night. You all experienced the lightning. It was rough last night. So what happens with lightning is there is a charge buildup. There's friction in the clouds. You know when we see those clouds that goes up like this, you know it's coming. Okay, there's a lot of friction, so the particles rub against each other, and then you can have two types of lightning. You can have lightning from one cloud to the next. So the one cloud can be very negatively charged, and the other cloud slightly negative or neutral, whatever. And then there's a discharge between the two clouds, or between the cloud and an object on Earth, a high tree or a tower or a what. Okay, right. Then I want to show you another thing. Yes?
Are you recording?
Yes? Okay. No. Right. So here we have a jersey and a balloon. Okay. Now I'm going to rub the balloon on this jersey here. Okay. And I'm going to let the balloon go. What happens? It's attracted to one another. Why? Because, reset. When you rub it on there, the electrons are transferred from the wool jersey to the balloon, as you can see there. So the balloon is very negatively charged, the jersey positively charged, and they attract one another. Okay, so positive and negative attract. Now, they touch and there's no transfer of electrons. The transfer only happens when it's a certain type of material. There's not always a charge difference. A discharge, a charge jumping. It depends on the type of material. Okay, so I want to go back to the notes. So here we have a transfer of electrons is when the two objects touch or when they come close to one another. I actually want to do something else as well. Yeah. Now, my experiment might not work because of the rain last night. Okay, so it uses a lot of moisture in the air, so it might not work, but okay, you see what happened? Okay, so when I bring this close. Alright, so when I rubbed it, there was a transfer of electrons, negative, my hair is now slightly positive, and when I bring it close, there is a attraction between the two. Alright, now we call this, I wonder if this will work. Does it work? No. Okay, so what happened is I discharged the balloon. It's not that negative anymore. And when I did this, I discharged my hair. There's a transfer until it's neutral again. So what are we busy with? Oh, transfer of electrons. There was something else that I wanted to say. Oh, so when I do this, there's a transfer. And when it comes close to each other like this, we call it polar. Does it do it? We call it polarization as well. I'm going to speak about that in the next lesson. Okay. Right. So we have transfer of electrons. Electrons being transferred so that objects what. Okay. So let's look at what that is. Transfer of electrons. Okay. If two objects with unlike charges, so unlike charges does not mean opposite. Okay, unlike does not have to be negative and positive. It can be very negative with slightly negative, or neutral with positive. So it just means they are not the same. Unlike charges, touch. So when there's a touching, there is a transfer of negative electrons. It's only the electrons that can move. Okay, so when they touch, there's a transfer of electrons that occurs, and then important, until the charges on both objects are equal. So they will transfer until there's no more difference in charges, until they are the same charge. So that's what happened with that John Travolta, the thing where he rubbed his foot against the floor. All right, and then he put his hand next to the door. So there's a discharge until they are equal. So what happens with the clouds last night is there's build-up of charge, and then there's lightning, that the charges jump until the two clouds are equal. But then there's friction again, and then it jumps again until they are equal. Friction again until they are equal. All right, so very important, until both objects are equal in charge. Right, now let's quickly look here. Originally, this thing on the left-hand side has one item.